Hello everyone. In this video, we are going to discuss about how CMake will work. Before watching this video, please watch ARM-based GCC cross-compiler installation so that you can install CMake in your terminals. So I will open UCRT64 in my Windows computer. Use command pacman hyphen capital SYU. It will update your files. Then use pacman hyphen s mingw hyphen w64 hyphen ucrt hyphen x86 underscore 64 hyphen cmake. It will ask you to install a cmake. Just give yes. It will install cmake and check cmake hyphen hyphen version. You can see the versions here. Similar way you can install for ninja as well. Instead of cmake, use hyphen ninja. Now you can check ninja version as well. So this is how you can install a CMake utilities. Okay. Now go back to our project structure. Here I have a startup file, main file, linker file, everything I have already created it. If you didn't watch the previous videos, please watch it. I have already posted it in my previous sections. Okay. Now come back to our source code repository and create a folder called build. This is for a temporary to understand how CMake is working. I will create a build. Under build, I will create one more build to store all the executable files. Now I will clear my terminal. Now I will create a one more file called C capital M make list capital S and .txt. CMakeList.txt. So this is your main file to create a CMake. First, I have to create a CMake minimum required version. So here I will check my CMake version now. CMake hyphen version. I can see 4.3.3. So here I have to use version less than 4.3.3. So this is the first step you have to do it in CMake file. Then I will configure the embedded target. So I will set a variable CMake system name. This is one of a variable and I will use generic, meaning this is not for Windows or Linux. It is for a embedded bare metal system. Okay, next I will create one more variable set CMake hyphen underscore system underscore processor. Which processor I'm going to use? ARM. Since I'm using STM32, it is ARM controller. I'm using that. And one more variable CMake try compile underscore target type. So here I'm using a static library. So meaning we should not use a computer libraries to create a executable. So I'm using this. Now we have to create a project. What is the project spec? I will create a project name as my first project and I'm going to use a C program and assembly code. So I have configured my project here and you can see .s and .c files are there. Okay, next we have to configure the toolchain for our project. So I will create a variable called set CMake underscore C underscore compiler. So I have to set a compiler name ARM none EABI hyphen GCC. If you didn't watch the GCC installation, please watch that video. Then we will create a one more variable for a assembly compiler. So I'm using the same compiler for assembly. So I just change the variable name only here. And I will create a one more variable called object copy. This is to convert the binary and X file using ELF file. So just I'm storing it in one of the variable. Later I will use it. So this is the toolchain configurations. Now we will set the MCU flags. Now I will create a variable called MCU flags space double within double quotes. I will use hyphen mcpu equal to cortex hyphen m4 space hyphen m thumb. So this is my MCU flags. Now I will configure the compiler flags. Set and I will create a variable called CMake C flags within double quotes dollar MCU flags I will consider here and additionally I will take a standard equal to C11. It will take the latest C standard hyphen O0 for optimization hyphen wall for compiler warnings and no stand for it should not take Windows libraries. Now I will create a one more variable for assembly flags. I will just use only MCU flags. It is not required to use other flags. Okay. Next we have to set the output directory. Since I have already created it, but it is not required to create it manually. So what I will do, I will create a variable CMake underscore runtime underscore output directory, and I will use CMake build binary directory. Under CMake binary directory, I will create a one more folder called build. Now the CMake runtime output directory will store the path of the build folder. Okay, this is my final output directory. Okay, now I will create a linker script path and I will store it in one of the variable. Set a linker script. This is a variable, and I will take the linker file path from CMake source directory. CMake source directory is CMake list.txt. That is the CMake source directory slash under platform under STM32 F446RE slash linker slash linker.ld. So I will fetch the linker file path and I am storing it in linker script variable. Okay. Next I have to search for the source files. I'm using a file keyword and I'm using global recursive C source for a variable dollar CMake source directory from the base directory slash platform slash STM32 F446RE. I have to fetch all the files under these folders. So I will copy paste this path here. Okay. Now in case if you want to add additional C files from the application folder, just you can create one more path for the application folder. So whenever you are using file, you have to use the file extension to search. This is the important thing here. Okay. Now we have included C source files. Now I will create a one more variable called assembly source files. So here it will include all the assembly files. So I will create a CMake source directory, which is base directory. From here, I have to search the path of the startup file. So I will paste the path of the startup file from the base directory. Now I have set the ASM source file here, source variable here. Okay. Next I have to include directories. In case if I want to include any directories, I have to use keyword called include underscore directories dollar, and I have to use a CMake source directory, which is base directory. And I have to include the path of the header files. Just I have to include the folder names from where I have to include. As of now, I'm just using some folders. In case if you have some header files needs to be included, just put the path here. Okay. Now we have to create a executable file for a embedded program. So I will use a keyword called add underscore executable and project name. So my project name here is my first project. Initially I have defined, right? Okay. Now I have to include my source files. So C sources. Here I will have all the .c files, and I have to include assembly files as well. So this is also I have included. Now I have added all the executables under my first project. Now we have to set the properties of the executables. So this is one of the keywords, set target properties for my project name, which is my first project. Sorry, I will copy project name. Okay, space properties space, and I will add a extension in suffix with .elf. This is the property of my executable. Otherwise, it will create a exe file. Now we have to create a linker options using target link options keyword. I will use my project name, that which is my first project, and I will use a private keyword, meaning it will apply only for this project. -t for to include a linker script, and I will add a linker script path here, and I will use -wl to enable linker options, comma, hyphen map to create a map file. Now I have already know the path of the build files as to store. So I will use my build folder path slash my project name with extension of .map. It will create a map file and it will store it in build folder. This is my linker option. Now all of my build files will get stored in the build folder. Now I want to create a X and binary generations using ELF file. So I will use this as a custom command. So I will use a keyword called add custom command. Target is my project name, my first project. This is my project name. And after executable during post build stage, I have to create a binary file and X file. Okay, the command here is I will use the CMake obj copy. This is my binary conversion tool which I have already initialized here. Okay, now I have to use hyphen o space ix and I have to put a .elf file here. So what I will do, I will put a path of the ELF file here. So dollar CMake runtime output directory, which is my build folder, and I have to select the ELF file. So my ELF file name is my project name .elf. So it will use my ELF file and it will create a X file. I will copy paste this again and I will just change the extension. So what it will do, it will use ELF file and it will create a X file. That is the meaning of this particular command. Now I want to create a binary file as well. So I will create a one more command. Instead of x, I will use binary. I'm using ELF as the source. Instead of x, I will create a binary. So this will create a binary file. So now all these files will get stored it into build folder. Now I will use the one more custom command to flash my binary file into my controller. So I will use add custom target and I will use command st hyphen flash write the bin file to this particular address 0x08000. So this binary file will get flashed into this address. Now to compile this CMake list, I have to move to build folder using cd build. Now I have moved to build folder. Now CMake -g ninja space double dot from parent directory create a ninja build system. This is the meaning of this command. So now if you go back to build folder, you can see all the ninja build systems got created when we run this command. Okay, now to compile this build system, I have to use CMake -build space dot. So it will create all the executables, binary, ELF, X, map file using linker files. Okay, now we will close this and I will clear the terminal. We will start from beginning now to compile. I will go back to the parent directory and I will force to remove the build folder using this command. Now you can see my build folder got removed. Now to compile, I have to create a build folder and go inside the build folder cd build. Now I have to run the ninja build command using this. So it will generate the build system under build folder. Now you can see all the build systems got generated. Now I have to compile using build command. So if I run this command, it will generate all my executables under build folder. You can see binary, LFX and map files. This is what a CMake file will do. In case if you want to flash the software, you can use this command to flash the software. Since I didn't connect it to my controller, so it is throwing error. If you want the source code of this project, please do comment. I will share the GitHub link. Thanks for watching the video and do subscribe for this channel.